All right, let's get right into it. Today, we are pulling back the curtain on a world that's usually hidden in the shadows. We're talking about the place where national intelligence and the absolute cutting edge of science collide. We're going to see how the hunt for a strategic advantage pushes intelligence agencies to explore not just new gadgets, but the very fabric of the human mind itself. This is going to be fascinating.
So every good mystery starts with a clue, right? Well, ours begins with a digital breadcrumb, a little trail that hints at a whole world operating just beneath the surface, a world with its own set of rules that you and I are definitely not supposed to know about.
Check this out. This is a quote from an actual email. It's from an FBI agent on a joint terrorism task force sent to a guy named Gary Beckham. And the subject? Making contact with people at the CIA and the DIA. The tone is polite, sure. But read between the lines. It's basically saying, yeah, there are rules for this, and no, I'm not telling you what they are. It just makes you wonder. Contact about what, exactly? What's so sensitive? And then you see this. This kind of warning label gets slapped on documents from inside that world all the time. It's a very clear signal that we are way off the public map here. You take that cryptic email and you pair it with this kind of warning, and you immediately get a sense of some really deep secrecy. So that's really the core question we're tackling today. When these agencies need a scientific edge, what kind of research are they funding? What's so important that it needs these secret, unwritten rules for even talking about it? Well, the answers are going to take us down two very different, but you'll see surprisingly connected paths. Okay, first, let's talk about what's plausible. And I mean plausible right now. This isn't science fiction anymore. We're talking about the real, fast-moving world of cognitive neuroscience. And you better believe the intelligence community is paying very, very close attention to anything that can help them understand and maybe even influence the human brain.
See, if you want to influence the brain, you first have to see what it's doing. You have to watch it work. A big report from the National Academies back in 2008 laid out all the tech they were interested in. Things like EEGs and fMRIs. These aren't just for doctors' offices. For intelligence, they're like windows. They let you watch the brain's electrical signals, see where the blood is flowing. Basically, they let you see thought, decision-making, and emotion as it happens.
So why do they care so much? Well, that same report gets right to the point, and the potential uses, they're just staggering. We are talking about making a soldier think faster and better, creating mind-controlled weapon systems, spotting a lie without a polygraph, heck, even figuring out how to just switch off an enemy's will to fight. The key takeaway here is this research isn't just for kicks. It has a very practical and very serious end goal. This quote from that report just says it all, doesn't it? The top-tier scientists advising the intelligence community basically said the sky's the limit. The only thing holding us back is our own imagination. But here's the kicker. If this is the plausible stuff, it really makes you wonder, what does the speculative stuff look like? And this is where we take a hard left turn. We're leaving the well-lit labs of the National Academies and heading straight into the seriously weird world of theoretical physics. If hacking the brain is about what's coming soon, this is about exploring the absolute ragged edge of what might be possible someday.
Okay, get ready for this concept. Quantum superluminal communication, or QSC. This idea comes from a 2003 paper by a physicist named Gao Shan. And what is it? Forget everything you know about communication. This is a theoretical way to send a message instantly, across any distance. Not fast, not nearly instant, I mean zero delay. It's basically the ultimate dream of communication. Totally secure, impossible to jam, and instantaneous.
So how on earth could that even work? Well, the paper lays out this wild chain of logic. It starts with something real, a truly bizarre feature of quantum mechanics called non-locality. It's that spooky action at a distance Einstein talked about, where two particles can be linked across the universe. Gao Shan then argues that this implies there's some kind of hidden universal framework connecting everything. And here's the massive leap. If you could tap into that framework, you could send a message instantly. And what's the key to unlock it? A conscious human mind, a quantum observer. And then the paper drops the bombshell. It doesn't just hint at it. It comes right out and says that what we call telepathy might actually be proof that the human brain can already do this. It directly connects this super advanced theoretical physics to what most people would call a paranormal ability. I mean, wow. So you have to ask, why would the intelligence community, which lives and breathes hard facts, even give something like this the time of day? Well, this slide really gets to the core of it. From a purely scientific view, this theory is way out there. It's unproven, speculative, on the fringe. But for an intelligence agency, the math is different. For them, the tiny, remote possibility of a perfect communication method is so revolutionary, so game-changing, that they have to understand it. Because the only thing worse than it being impossible is your enemy figuring it out first.
And that brings everything together. This is where these two completely different fields, the very plausible neuroscience and the way out there fringe physics, turn out to be two sides of the very same coin. And that coin is the relentless, never-ending search for an advantage.
And here it is, straight from the horse's mouth. The #1 mission is technology warning. What's the biggest fear in the intelligence community? Technological surprise. An adversary suddenly showing up with something you never saw coming. So to stop that from happening, their job is to keep tabs on scientific trends everywhere, from the biggest university labs to the absolute weirdest, most obscure research papers. You can really think about their whole strategy like this spectrum. It's not one or the other. They look at the plausible stuff, like neuroenhancers they can use today. They watch the emerging tech, like brain-controlled drones for the near future. But they also keep an eye on the really theoretical stuff, and even the absolute fringe, like quantum telepathy, just in case that 1 in a million long shot actually pays off. It's all part of the same job. Leave no stone unturned. And they are playing the long game. That National Academy's report recommended that they monitor this stuff for a time frame of over 20 years. This isn't about solving today's problems. This is about trying to secure an advantage for the next generation. It means you have to be willing to look at ideas that sound completely impossible right now. Which really leaves us with one final big question. In this high-stakes world of looking into the future, where national security is on the line, how far is too far? At what point does the search for an edge push you right past science and into a world of pure speculation, secrets, and really profound uncertainty? It's definitely something to think about. Thanks for joining me.